Okay, number 111, actually, yeah, it's 111, and 111 through 114 are all asking very similar things, so I'm only going to look at one of these, okay? And they all, on the surface, are simply instances of deMorgans laws. And we talked about that very clearly in class. A union B prime is what? Well, people will want to distribute the prime through the union and write A prime union B prime. But if you check that out and test it, it turns out not to be so. For example, if you do the Venn diagram for this, it looks different than the Venn diagram for A prime union B prime. But it does look the same as the Venn diagram for A prime intersection B prime. And deMorgans laws say that if you have two sets with a union or an intersection, and you have the complement, the prime, that you can distribute this through there, sort of, as long as you reverse whatever the union or intersection is. So if you've got a union, it becomes an intersection. If this was an intersection, it would become a union. Okay? So you want to at least know that that's so, but it's not hard to see because you can easily test it. Okay, A union B, if we got the sets A and B, well, here's A union B. And that's in white. And then A union B prime is everything in the universe that's outside of A union B, so that would be this whole region here that's not within the set A union B. Okay? Now what about A prime intersection B prime? I'm not going to label these, but I'll use A on the left and B on the right. Okay? Well, I'm going to use a couple of other colors here. And let's use colors of contrast. I'm going to use this bright orange to indicate the set A prime. A prime consists of everything outside of A. And that includes a good portion of B. Okay? Now, let's see, green should contrast nicely. B prime is everything outside of B. So here's our B set, and I've got to shade everything except what's in B. Yep. Okay. So now I've got this, everything that's shaded here, well, okay, everything that's shaded here would be A prime union B prime because union is inclusive. And everything that's shaded here clearly is not what we've got here. Okay? What we want though is A prime intersection B prime. Okay? And the intersection consists of everything that's both in A prime and in B prime. That would consist of everything that's shaded in orange and in green. Okay? So let's see. All this stuff outside of A and B is shaded in both colors. Okay? There's a little part of this one that isn't shaded, but that's clearly part of A prime. But what's in here isn't in B prime. It's not shaded in green. Now, it's not, I'm sorry, this is in B prime. This is not in A prime. It's not shaded in orange. Okay? Now the stuff here, the part of B that's shaded is only shaded one color because it's not in B prime. Okay? It's got to be in both A prime and B prime to be in the set A prime intersection B prime. So that A prime intersection B prime won't be this part of B, okay, because it's not part of B prime. Won't be this part of A, it's not part of A prime. Certainly won't be part of this unshaded region, which is in both A and B, so it's certainly not in A prime or B prime. It's all the stuff outside these two sets. I'll attempt to indicate that by kind of filling that in. And we see that that is the same as the purple region here. So that's how you could establish this using Venn diagrams. Of course, you got to practice with Venn diagrams. That's not necessarily a simple task, especially when you first see it. You might have to come back to it today and then a couple days later until it becomes a little clearer to you. And you have to maybe do problems of increasing complexity in order to really understand how to analyze things with Venn diagrams. Anyhow, that's one instance. Then you can also then test that A intersection B prime equals A prime union B prime. The regions would be somewhat similar to the regions you have here, but you'd be doing the complement of the intersection here and the union of the two complements here.